video, you'll learn the difference between an element, a mixture, and a compound. Firstly, some definitions. An element is a substance that cannot be broken down into anything simpler. A mixture is a substance consisting of two or more substances mixed together, not in fixed proportions and not chemically bonded. And a compound consists of two or more elements chemically combined. So consider the two elements iron and sulfur. We should perform 4 tests. Firstly, on iron and sulfur separately. Secondly, on a mixture of iron and sulfur. And thirdly, on a heated mixture of iron and sulfur. The 4 tests we are going to do are appearance, action of water, action of an acid, and finally, action of a magnet. So starting with performing the tests on iron and sulfur separately. Iron filings are dark grey crystals, whereas sulfur is a bright yellow powder. You will see that the iron sinks and the sulfur floats. With iron filings, you can see bubbling. The iron reacts with the acid to produce hydrogen gas, which can be tested for by holding an empty tube over the tube of iron filings and acid. After a short time, we remove the upper tube and immediately put a lighted splint to the open end of the tube. A pop is heard indicating hydrogen gas. With sulfur and hydrochloric acid, there is no visible reaction. If the iron is sprinkled onto a sheet of paper and a magnet is moved underneath the paper, you will see the iron filings follow the magnet as they are attracted to it. When the same is done with the sulfur, you will see that the sulfur is not attracted to the magnet. So from these 4 tests, it can be seen that iron and sulfur are 2 completely different elements and behave differently in the 4 tests. Iron is a metal element, sulfur is a non-metal element. So now let's look at performing those same 4 tests on a mixture of iron and sulfur. So some iron filings and sulfur powder are mixed together on a piece of paper, and we now have a mixture of iron and sulfur. If we add a bit more iron and mix, we still have a mixture of iron and sulfur. We could add a bit more sulfur and mix. It's still a mixture. As said earlier, the components of a mixture, in this case iron and sulfur, are not in fixed proportions. So let's now perform those same 4 tests on the mixture of iron and sulfur. In the mixture, we can clearly see the dark grey crystals of iron and the bright yellow powder of sulfur. We can see that the iron in the mixture still sinks and the sulfur floats. The components of the mixture have separated. The iron in the mixture reacts to produce hydrogen gas as before. It gives a positive pop test when mixed with air and the mixture ignited. The sulfur in the mixture, however, gives no visible reaction. As the magnet is moved underneath the paper, you will see that iron is attracted, but the sulfur is not. Again, as in the test with water, the iron and sulfur can be separated, illustrating the fact that the components of the mixture can easily be separated by physical means. From these 4 tests, it can be seen that the components of a mixture behave in the exact same way as they did when they were on their own. That is, they retain their separate identities. Finally, let us perform the same 4 tests on a heated mixture of iron and sulfur. For this, we need to carefully select our amounts of iron and sulfur. If the mixture of iron and sulfur is heated briefly and then removed from the flame, a red glow spreads throughout the mixture which turns black. Heating the mixture causes the iron and sulfur to bond chemically to form the compound iron 2 sulfide. This can be shown by the equation. Now let us look at how the compound iron 2 sulfide behaves in the 4 tests. It's a black solid, different appearance to either the iron or the sulfur. It all sinks, there is no separation. The reaction between the iron 2 sulfide and hydrochloric acid should be done in a fume cupboard, as when the hydrochloric acid is added to the iron 2 sulfide, bubbles are seen, but the gas formed is hydrogen sulfide gas, which is toxic. As the magnet is moved underneath the paper, you will see that the iron 2 sulfide is not attracted as it is not magnetic, so we cannot separate the heated mixture. However, as often happens in class, if the wrong amount of iron or sulfur is used so that there is excess iron, then the iron 2 sulfide will be attracted to the magnet because of this too much iron.